and welcome to No Physics with me. Hope all are doing good. Yes, so we have already started with Physics CBSE Class 10, Chapter 10, Light, Reflection and Refraction. So we have already done with 6 sessions and this is our 7th session, and in this session we are going to discuss about refraction only. So in previous session itself we started with refraction. We clearly understood what is refraction through live examples. Yes, so in this session we are going to see refraction through a rectangular glass slab, and also we are going to see what are the laws of refraction. Clear? Yes. From the heading you can understand what we are going to see. So refraction through a rectangular glass slab. So let us consider this to be a rectangular glass slab. Inside this, how refraction takes place we are going to see. Okay, so let us consider a rectangular glass slab ABCD. Clear? Now I am going to pass an incident ray. So let this be our incident ray, say EF. So when we have an incident ray, the next what we will be drawing? Normal, right? So normal is a line drawn perpendicular to the surface, 90 degree. Okay, so you have incident ray, you have a normal. Now what is happening? From air to glass it is moving, right? So when there is a change in medium, what will happen? Refraction, right? Bending of light takes place. Whether it will bend away from the normal or towards the normal. So this is nothing but rarer medium and this is denser medium, right? So from rarer to denser it moves towards the normal, we have seen. So let light bends like this. Okay, towards the normal. Clear? Yes. Now at this surface what is happening? Again from glass to air it is passing. From denser to rarer. Okay, so let this be the normal. Okay, so this is the incident ray. For the second case we are considering, this be the incident ray, this is the normal. Now we want what? Refracted ray, because it is changing the medium from glass to air. Now tell me whether it will bend towards the normal or away from the normal. Think and say. It is denser medium and this is rarer medium. So denser to rarer, it will move away from the normal, right? Yes? Okay. So this is the direction and it moves away from the normal. So this is the first thing that we'll understand. Okay. So first you have an incident ray EF and you draw a normal. When you see that it moves from one medium to another, rarer to denser, the bending of light takes place. It bends towards the normal since it is moving from rarer to denser. Now this refracted ray, this is nothing but incident ray and this is a refracted ray. Okay, now let us consider this to be the second case. If we consider so, this refracted ray acts as the incident ray here, right? Yes. Now this becomes the incident ray and this becomes the refracted ray and this is our normal. Now bending takes place away from the normal since it moves from denser medium to rarer medium. Clear? Yes. So when we consider this as a single part, we will say this as incident ray, this as refracted ray, and the ray coming out here is called as the emergent ray. Means when we consider this as a single case, okay, we will say this as the incident ray, this is the refracted ray and this is the emergent ray. Now what you have to do is, you have that incident ray, right? Now try to extend this line. Okay, my diagram is not perfect, okay, so using scale you can do it, okay. If you do it with the ruler you will get the exact diagram. So from this how can we conclude what is our inference? So when you see this ray and this ray, why we are extending the incident ray? Actually the light travels in a straight line, right? That is how we have learned. So when we consider that, the incident ray has to come like this. But since there is bending, since there is a change in the medium, bending of light takes place and the emergent ray appears to be like this. So when we compare these both, what is our conclusion? These both rays appear parallel. So the emergent ray and the extended incident ray, when we compare, it appears to be parallel. Am I right? This is nothing but extended incident ray and this is your emergent ray. When you compare both, it appears to be parallel and it is shifted laterally, or you can say it as it is displaced laterally. Actually the position should be here, instead it is here. So there is a lateral displacement. Clear? And there is one more thing. See how much angle of incident you have given, the same angle will be here for the emergent ray. You understand? So you can say it as it is equal and opposite. Okay? Because how much it is bending here, the same bending takes place here in the opposite way. Clear? It is bending towards and here it is bending away. So when you see, both the angle will be equal. Okay. So inside a rectangular glass slab, what are your conclusion? Your refraction takes place and the refracted ray is laterally displaced from the incident ray and both the rays are parallel as well as equal and opposite. Clear? So this is what you have to learn it from the rectangular glass prism. Clear? Yes. Is there any angle of deviation? No. Yes? Okay. So now I hope you are all clear with refraction through a rectangular glass slab. Yes? Now I have a question. If your incident ray falls normally at the interface of these two media, then how will be my refracted ray, or what is the path of my light? Okay. So the question is like this. Incident ray, now I have kept some angle from the normal, right? Now instead of this, if the incident ray falls along the normal, so how will be my refracted ray? It goes undeviated. It means it goes along a straight line. When your incident ray falls normally, it will go along a straight line. There won't be any bending. Okay. This is because the incident ray falls normally. So there is no angle between incidence and the normal. So obviously there won't be any refracted ray. Correct? So the line, the ray of light goes straight. You understand? Yes. Now we will go with what are all the laws of refraction. Yes. So now before getting into what is laws of refraction, we will understand one more thing. Why is the refraction taking place? Why there is bending of light? You may have an answer like it is moving from one medium to another medium. Yes, okay, it is moving from one medium to another. So what is the change that is happening? Consider, here you have air and water. Yes, and we said the density changes and because of that there is bending. Yes, so actually when it is highly dense, okay, so the light cannot pass through in the same speed as it is in vacuum, right? Think the speed of light in vacuum is 3 into 10 power 8. But the speed of light in air is somewhat 0.3 lesser than this, 0.003 lesser than this. So we will consider it to be same, 3 into 10 power 8. Actually it is not 3 into 10 power 8. It is lesser than this, but its value is negligible. In that case we will consider the speed of light in air is 3 into 10 power 8. Whereas the speed of light in water is 2.5 into 10 power 8. It is lesser than air. That is, the light cannot travel in the same speed when it travels through different mediums. It reduces. That is why there is bending of light. So, why is there a bending of light, or why refraction takes place means there is change in the speed or the velocity of light in the two different mediums. That is the reason bending takes place. Now you are clear? Yes? Okay. Now we will get into laws of refraction. Just like laws of reflection, we have two laws of refraction but quite different. Okay. So laws of refraction, first law is quite as same as second law of reflection. So what does the second law of reflection states? The incident ray, the normal and the reflected ray at the point of incidence all lie in the same plane, right? So here there is a slight change. The incident ray, instead of a reflected ray, we will write it as refracted ray, and the normal at the point of incidence of two transparent media or medium lies in the same plane. So this is the small difference between the second law of reflection and first law of refraction. So that instead of reflected ray, here we will write it as refracted ray. Clear? Yes. Second law states that the sign of angle of incidence divided by the sign of angle of refraction is equal to a constant. I'll tell you what it is. Note down, this is also called as Snell's law. So if you get a question like states Snell's law, you have to write this law only. So this law was given by Snell's, and that is why it is called as Snell's law. So the sign of angle of incidence. So if I write it as formula, I can write like this: sin I by sin r is equal to constant. Okay. Okay. The sign of angle of incidence to the sign of angle of refraction is equal to a constant, and this constant is known as refractive index. So we will learn detailedly about this refractive index in the next session. So for now we will understand this law. Okay. So what is sign of angle of incidence? For this there is a special condition that for a given pair of media and for a given color of light, so this is the most important thing that you have to use or include in this law. Only for a given pair of media and for a given color of light, this law holds good. You understand? So it means when I take angle of incidence divided by angle of refraction, it will be equal to a constant value they are saying. That is, say, now I am considering air and water. Let my incident angle be 30 degree. For example, I am telling, and this be 45 degree. Okay. So when you find angle, that is sine of 30 degree divided by sine of 45 degree, you will get a value, right? That value will be same even if you change the angle. For example, suppose here you consider it to be 60 degree and here you consider it to be 30 degree. Now if you find the sine of angle of incidence to the sine of angle of refraction, you will get the same value what you got previously, but on the condition that you are going to keep the median the same. That is, in first case, if you consider this to be air and this to be water, now also you are going to consider the same air and water. You will not change the medium. If you change the medium as water to air, then this value will not be a constant. You understand? So, on a given pair of medium, that is air and water, if you consider, even though the angle changes, this value remains constant. That is what the meaning is. Okay, and for a given color of light, suppose you are keeping air and water. In first case you are using blue light, and in second case if you are using red light, this value will not be a constant. Only for a given color of light and given pair of medium, even though you change the angle, this value is going to be a constant. This is what is said by Snell, and this law is called as Snell's law. Clear? Yes. Hope you are all clear with the topics discussed today, right? refraction through rectangular glass slab as well as loss of refraction. So if you have any doubts, please do post your doubts in the comment box. And if you like this video, do share it with your friends and do subscribe my channel. So thank you for watching this video. Thank you for all the support given. Keep supporting. So thank you.